Well, thank you very much for coming. Thanks for not being interested in Hadoop cluster management, but if you want me to change the topic, I can talk about this as well. But I actually would like to talk about more kind of a higher level concept, but you guys help me to zoom as much into the technology as you want to. You maybe saw that graphic before. There was two companies recently that have had a very long conversation about who contributed the most code to Hadoop. That's why we made it a t-shirt. My Hadoop is bigger than yours. In case you want some, just come to our booth. Anyhow, so what I really would like to talk today is about, it's not about big data. I think big data is a big buzzword from big companies to make big money. But I really would like to level us back. Where is Hadoop really helpful, and how do we have to think about this? Because maybe some folks in that conference told you Hadoop can print money and do your dishes. It's actually not true. And why do I think I can talk about this? Well, so I'm coming up on 10 years. I was one of the first 3 guys that started at Nudge. Anybody heard about Nudge? Few? Oh, Kevin, you heard about Nudge. Few more? Okay. So Nudge was an open source search engine project that actually implemented the Google MapReduce papers, and this is where Hadoop was born. Next year I will graph how many hands I see that heard about Nudge. It's kind of interesting. It's going down. But who heard about big data before? Just to make sure that your right arm is working. A few, okay, good. All right, so before I really start with my presentation, let me tell you a story. This is actually Gregor McRaven, I think you pronounce him. But in his movie, he plays his character, Nick Layson from Baer. And he's a very ambitious asset trader in Southeast Asia. And he's super successful, and this is a real story, right? These are just a few screenshots from this movie, but this is a real story. He's a super successful young man that trades assets and is becoming really, really rich within a very short period of time. What he did is he traded on the assumption that the Asia market is very stable. But actually what happened is that there was an earthquake in Japan, and obviously that totally brought down the market. And all of his assets within just a few hours lost tremendous of value. Now, of course, he went into panic because what he did is he traded way beyond his risk that he was allowed to trade. He invested way more money because it went so fantastic that he put really the bank on the line, thinking he will make billions and billions of dollars. And then even worse, when it came to the point that everything is lost, you know, he obviously tried to recover from the risk, he started hiding his losses. And what he did is he used the advantage of, I call it the data jungle in banks. I know, so I work for a bunch of banks, but I'm personally still 99%, in case you wonder. We work for a lot of banks, and it's amazing. Some of them have one database for every 7th employee. And what Nick actually did is he balanced out his P&L by creating fake records in a different database that kind of offsets his losses. And you would think that today in the 21st century, you're actually not able to do this, but you know, you can just create records and move data around, right? You can move stuff from Oracle to DB2 to maybe an MS SQL. And this is how you kind of massage the P&L in a bank, where you would think if we're talking about hundreds of millions of dollars, somewhere alarm bell should go on. Well, it didn't really, and he kept trading and he tried to recover from his losses, but he actually did not recover. And back then, famously, he did hide all of his losses on an account, I think with 8 eights. What's a, I think, Chinese lucky number, but I'm German, so I'm not really sure about this. But, you know, in the very end, they catch him, of course, though the problem is Barings Bank, basically one of the oldest British banks, is going bankrupt on this. And, well, if you think this is a unique situation, well, Nick was the first one, $1.4 billion in losses, undiscovered because he basically gamed the databases. You maybe heard about this gentleman who created $6 billion in losses for a French bank, and they discovered him again way too late. And this gentleman, $1.4 billion, and maybe you read the news recently, $7.5 billion burned. In case you wonder, the NASA has $76 billion this year's budget. Together, those four gentlemen burned to $26 billion. I would like to have 0.001% of that. And I give the other 99 to you guys. But think about this. So what's the picture I'm trying to paint here? There's a few gentlemen that actually know the data infrastructure in a bank that can burn to more money than the NASA spends in shooting people to the outer space by gaming the data system. How can this happen? 21st century. We connected on Twitter all day long. How can a bank not discover the loss of $17.5 billion? I guess they don't count money anymore as they used to do. But you would think they can do like a select star from asset database, sum up. It's a simple query. You should do this. Well, let me go a little bit more in that detail. But before I go there, let me point a few other observations out. This is 2009 Hadoop ecosystem. 1, 2, 3, 4, 5, 6, 7 players. This is 2012 Hadoop ecosystem. We counted 111 companies that do big data. And I think in the last 24 hours, we have at least 10 more. There's big data pretzels, big data fridges, big data, everything, big data. It's pretty intense. But again, my talk's about it's not about big data and big data. So let me get into a little bit more detail. What you guys are observing, and thank you for joining me to share this with you, is Gartner calls it the hype cycle, right? So first we have some amazing technology. Again, that started with Nudge in 2003. And then in 2006, Yahoo jumped on board. And you know the history. Facebook today runs 70 petabyte analytics. I think they said 100 petabyte now of your data, analyzing your data. Any Facebook folks here? Okay, I should be careful. I'm European. You know, we have different kind of privacy laws in Europe. So the next thing is there's a peak of excitement. And I think that's where we are right now. Where, again, we have a big data fridge, and we have a big data car, and a big data everything. But you know, what will happen is, and we observed this with some companies, what will happen is that actually people will start talking about where Hadoop is not doing dishes and not printing money. And we have kind of a situation of disillusion. And you know what? I would like to help with that disillusion a little bit today and really talk about it's not so much about the big data. Who has the biggest Hadoop cluster in the room? Hand signs? Oh, nobody. Who has the smallest Hadoop cluster in the room? I run one on my iPhone. And then eventually we come back and we realize that maybe big data and Hadoop is all just a new really cool tool in the toolbox, but you know what? It will not replace Oracle, ETL, or BI. It will not. Let me tell you very straight, it's not the new silver bullet for everything. And at some point, we will get to the point that we have the so-called plateau of productivity where we actually understand where the tools are helpful. So we right here, again, it's mostly downhill from here. But you know, here's another graph. It's called Crossing the Chasm, a very interesting book you maybe heard about. And it's actually the same situation. In the beginning, you have the innovators. And you guys are the innovators. You came here because you think MapReduce is super, super interesting and super exciting. Who's writing native MapReduce code? Anybody? One, yeah. Are you using VI? No? As development environment? 2, 3, yay. Pick, Hive, one of those tools. A few more. Cascading? No, okay. Jekyll? Okay, so the innovators then, turn into the early adopters. They understand the technology. There's high potential in the technology here. But then at some point, we really get to the point that the majority of people kicking in see the values. But the conversation from the innovators to the early majority changed from this is cool technology into where can it help us, where it's really making a difference. And then at some point, you have kind of the other folks coming. So again, we have to cross the chasm, we have to jump, and we have to change the conversation from how we manage Hadoop clusters into what can we actually do with this thing, right? And really, really take a perspective on this. So all of you know Hadoop is a storage and compute platform. Most of you, maybe, I don't know, you're super smart, but most of people I speak every day with, they always think Hadoop is a big data environment. Well, guess what? Years before we started implementing map, reduce, HDFS, we actually highly optimized for sequential data access. Instead of creating a random B tree that you usually do in an RDBMS database, what means as soon you write records with a high speed in that system, you have to constantly rebalance the tree. We just sequentially writing data on this. We did this long time before we added the distributed layer to Hadoop. But everybody always just thinks about the distributed layer. My Hadoop cluster is bigger than yours. How many gigabytes, terabytes, or petabytes is yours? You go in a bar last night and you're like, man, I'm on a petabyte soon. You saw the t-shirts, petabyte me. Anybody has a petabyte data yet? My mom has a petabyte soon. She's collecting videos, so. The beauty, though, is not just is highly optimized for local data access, it linear scales. We understand it. What does that mean? It means that Moore's law is kicking in. The reason I have a beautiful, beautiful smartphone that makes everything so easy to use is because I have stronger chips on that. I have a user interface in OS X and in Windows that makes me so much more productive because of Moore's law. And I think it is time that we understand that what Hadoop brings to the table is an acceleration of Moore's law for data analytics, where we really can invest more hardware into our problems than we could ever do before at a lower price. So here, just as a reference, in case you don't believe what I'm saying, this is a database hard drive that writes individual records. As you see, since you're writing a B tree, you're constantly moving the reading head. If you're actually trying to read individual records here, you move the reading head, and even though it is slow, it takes 5 to 10 milliseconds to move that reading head to find individual records. So the time to read 100 million, and this is the math, and I'll let you do this, the time it takes to read this 100 million records out there will be almost 6 days. Well, here's a Hadoop hard drive. And instead of moving the reading head for every single record, we position the reading head once, and then maybe you can see it here. We spin at full 7,200 RPM, or maybe faster if you have the fancy ones, to read the data. And for data analytics workloads, this is perfect. It's terrible if you try to find individual records, but for analytical workloads, it's actually, as you see, 1 not 5 days to read to the same amount of records. Now, the funny thing is, on the one hand side, we only had so much storage and compute in the Oracle databases. On the other hand side, we're using a random B tree, random read and write B tree kind of optimized data structure to do the data analytics, what are almost always full table scans, joins, aggregation. You always have to sequentially scan to the data. So I would argue that a company in Redwood Shores with a big O and with a red logo is selling us the wrong kind of thing for data analytics since a very long time. I'm not sure if you agree with that, but obviously Hadoop brings something to the table here. Now, if you say, well, SSDs will solve the problem, well, you're actually wrong. Sequential data access is magnitudes faster for SSDs as well as for memory, and this is log scale, because I just couldn't make this tiny thing work. So instead of 316 records a second, you can read 53 million for sequential data access on standard hard drives. This is a wonderful paper, and I highly recommend to read this. Adam Jacobs, actually, The Pathology of Big Data. You need to read this if you're in the space. If you didn't read this paper, don't come to the next, sorry, no, just do what you want. More high-level observations. Hardware costs went dramatically down over the last decade. On the other hand side, good luck finding a data scientist. The going rate, Silicon Valley, just so you know that you can adjust your pricing, talk to your boss, $200,000. Right? If you're smart enough to really work with all the technology we're talking about here, you can make a lot of money right now. Go do it because it will change. Second graph, different observation. What really is the problem for all the companies that using this technology is that they barely have time to make decisions. The speed of business increased. We're pushing an iPhone in less than 3 months into the market. It took us 40 years to bring the microwave into the market. So we barely have time to make decisions. And now if you happen to read this wonderful book called Thinking Fast, Slow, that talks about two systems in our brain. If we are under pressure to make a decision, a business decision or a personal decision, our brain actually ignores statistical signals. We do emotional decisions. So as more pressure we have to make decisions, as worse we actually getting and doing informed decisions. And on the other hand side, data became way more complex. So the systems we use don't produce as fast insights anymore. So you heard about this too. Gartner calls it the 3 Vs. We have more data. And that's why most of all of us are here. We think, oh my God, it's a tsunami of data. Well, actually, you know what? We have MMP databases since, what, 15, 20 years now? Right? There's Teradata, and they do a wonderful job, and they do wonderful money since a lot of time because of the data deluge. We have way more data. It's solved. It's understood. Greenplum, Vertica, Teradata, Exadata, it's all there. The challenges people have are there's more kind of data. We now analyzing machine-generated data, social media data, clickstream data, all that kind of stuff that we used to ignore because we only put our kind of structural database into our Oracle database. And the speed in which we have to integrate new data is actually significant increasing. If you made a social media strategy in your company, you actually already have to change it. Pinterest creates more commercial traffic on websites than Twitter or Facebook. I didn't measure it, but the speed in which things change is so incredibly high. Now, again, volume, velocity, variety. So let me give you an example. We work with different retailers, and their problem is customer acquisition costs. It basically means build a new store somewhere, right? If not a whole mall. The easiest way for companies to make more money is to increase customer lifecycle value, basically selling you more. But to do this, they need to understand customer interaction. Did the user actually came first in my store and then looked on the website, or vice versa? Is he coming back after I called into his call center? I really wish companies would check this more often. Does he have a good experience there? Can we cross and upsell him things? The reality of organizations today is they have a database, one database for every one of those systems. There's a CRM database, a product catalog, there's web logs, and all of those are data silos. And people running companies looking through a soda straw by only analyzing individual things. Anybody here is integrating web analytics with his sales data and his in-store sales data? Hey, Rito, good. Innovative. That's where people have problems. Why is this so difficult? Well, traditionally, we have a three-tier architecture. And we have this three-tier architecture because we had limited storage and compute. There was only so much Oracle you could buy for money. DB2, Teradata, Greenplum, or choose your favorite vendor. So we had a process we called, and have a process we call ETL, extract, transform, and load. And the funny thing is that now companies come and say, Hadoop is a great ETL tool. Well, guess what? We have distributed ETL since 15 years. The reason we do this is we put it into a static data warehouse schema, our star Snowflake schema. And I call this the General Motors approach. Any General Motors folks here? Okay, no. I call it the General Motors approach. It's kind of you design this beautiful 500 horsepower truck, Then you purpose-build a factory for that. It's highly efficient for that specific car. But boy, good luck if the gas price change. Right? You build a whole new factory. You build a whole new schema. Every time you have a new data source, you change the schema in your database. Even worse, you have BI sitting on top of that that's highly dependent on the schema. So every time you have new data, you change the schema and you change your BI. Every time you have a new question, you actually have to change the schema as well and all the ETL scripts. So you have 3 pieces of hardware, 3 vendors, 3 groups, highly coupled, independent, and constantly friction, right? The DBAs, usually they have a beard like this. They say, don't do anything on my Oracle database. The ETL guys constantly say, well, but we could add another table here. And the BI guys, the business user folks, like, oh, I have another question. Can you do another join here? Right? So we work for a bank. They have 250 data sources. And they have to bring it together to implement Basel II to make sure what I talked earlier about is not happening. 250 data sources. Finding the perfect star schema is an academic exercise that they wrote a program for. 1,600 tables. Good luck administrating that database. It's impossible. It's really, really impossible. So what we need to understand is that we now have Moore's law kicking in data analytics. That's why we have iPhones, macOS, Windows 7, or now 8, I think. We have user interfaces for a reason. Anybody running Linux on command line on his laptop? Just don't want to offend you. The reason we have user interfaces and visual tools is to make us more productive, because the only thing that you guys can't buy for money or your company is time, is your time. So what we can do instead is we take data as is and put it into Hadoop. We leave it as is. We don't create a schema. We don't use Hive. I'm sorry, no, Hive is not a cheaper MMP database. It's only support 30% of SQL. And you're doing something wrong if you have an unlimited storage and compute environment like Hadoop. Take data as is, put it in, and you know what? Just create dynamic views on the data. Do data pipelines. Create as many views and models of the data as you want, but do a schema on read instead of a schema on write. And I call this kind of the Toyota approach. Right? It's a dynamic data supply chain on demand. And instead of having 3 data warehouse environments in your organization, 1 for marketing, 1 for sales, 1 for IT, you have 1, and you're just feeding and viewing the data a different perspective. We can, by today, afford to recompute the data all the time to have different things. What you win is tremendous agility and flexibility in your organization. For structured and unstructured data. And if anybody comes here and says, oh, but it's not real time, please explain what real time is. Your ETL script before was batch anyhow because you had to create that random B tree anyhow. So the performance to load into an RDBMS is actually less good as Hadoop can do sequential reads on the data. So why can't other folks do this, obviously, is, well, they all build on standard SQL. Standard SQL requires structured data, a schema. And by the way, this is a 40-year-old language. Really? We spent like, let me count, 6 years to build Hadoop. 6 years. And it was the first no SQL platform, and we thought it's the biggest innovation, and now we install SQL-style tools on top of that. Man, you're cutting the ears up of the elephant. Structured data is growing, unstructured data is growing 4 times as fast as structured data. If you really actually just think structured data is what your organization makes tick, then I don't know. And the other thing is, all the BI tools we had, they expect response rates in seconds. Right? If I do a drag and drop in one of the visualization tools, actually the UI is frozen until the database comes back. Now, Hadoop is obviously no SQL. And again, that was an innovation, guys. That was the whole idea. Go back in Nudge mailing list. We had hundreds of emails discussing why we don't use Postgres or MySQL for Nudge, because we didn't have schemas, because we had sequential data access. And of course, there's, again, more machine-generated data. We can better understand how we interact with folks on our websites, how our servers interact with each other, where the security threats coming from, how trading logs look like. And it's batch. But it always was batch. There is no big data, real-time something. And your in-memory database is not big data anyhow. The problem is complexity. So let me tell you where big data, or the complex data, how I would like to call it, really kicking in and are really interesting. I see 3 pillars. Number 1, where we have structured and unstructured data. If you only have structured data, do not use Hadoop. Go with Greenplum, Vertica, or one of the free MMP databases. You will be much better because they are working ETL tools and working BI tools on top of that that are perfectly fine. There will be only, if there's any return of investment, it will be very, very small or negative. Look for a scenario where you have many data sources. If you just have one data source, you know, if it's just machine-generated data or it's just structured data, I think it's really not worth it. And look for folks that actually needs and have an agile access, decision makers that would like to get the answers quickly. You heard Phil Shelley from Sears this morning. You know, they got their decision-making process down to minutes, what used to be days or weeks. Look for those use cases, because if you just go and say, oh, you know, I'm offloading this from Oracle into here, you know, you're wasting your precious time. So here's a few things we see again and again. I call it advanced web analytics. You know, web analytics is kind of a well-understood problem, and there are products like Omniture, Core Metrics, Google Analytics, but they only tell you how much clicks on a website you got. Well, for a retailer, that's not so interesting. You actually want to, first of all, understand, are people first looking at pens and then choosing the shirt, or vice versa? Right? So eBay has this amazing use case where they increased 2% of their revenue just looking at some data. 2% eBay, make the math. But what is interesting is not just what maybe keywords at Google DoubleClick or Google Ads bring traffic, but actually converting. You want to bring your Salesforce or other data together, because all web traffic in the world is not very helpful if you don't make money with it, except you Instagram or Facebook. No, okay. Product cohort analytics. So we see a lot of gaming companies doing amazing things, right? They not just see when people find their website, when they sign up, how they're socially sharing, which tools they're using, how long they're in the game, when they're leaving the game, but when they're converting from a freemium to a premium user or buying so-called virtual goods. If you know what virtual goods are, please come to me, explain it to me. I'm not sure yet, but boy, they make $3-digit million kind of revenues. But we have other folks that we're working with. It's really, really interesting. So we have one company that did that, brings 7 data sources together, double-click data, web data, download data, installation data, then freemium to premium conversion, and then even all the other products they have. And they found that in that conversion pipeline, they had a big gap in churn, or a big jump in churn, where they lost a lot of customers. They changed something in that process that made it even easier to install and register the product, and they doubled their conversion rate. For those guys, that meant $20 million more within something like 10 months. If you help your organization to do that, I promise you, you have a different kind of paycheck. We see really amazing things around cybersecurity, different kind of data sources. Folks now can see a threat coming up in Europe, moving over Russia, attacking Windows 7 in the US, and it can be proactive. You can do different things. You can look at viral spread the very first time, bringing email logs, firewall data, scanner data together. There's amazing things you can do. And in times of, what is it, flame and all the good stuff that some very big hackers pushing out, that's kind of interesting. And then we really have an opportunity here to solve those problems that I talked about in the beginning. Right? If you can bring 250 data sources together, if you actually bring the trading system together with the database that holds the assets that you actually own, and maybe at the trading logs, yes, you will be able to see that the rotten assets with no value are actually not leaving your organization, your bank, but just moving from Oracle to DB2 to maybe an MS SQL that's in London and back, because you first time get a 360-degree view of your data that you couldn't get before because it took you years to integrate them, and everything changed faster than you can keep up with the traditional ETL, static data warehousing, BI kind of infrastructure. So really, really interesting use cases, 3 pillars that I observed in the last 10 years doing this. Again, I invite you to have a very open and critical conversation about what big data means to you. Big data to my mom means something different to the folks we're working with, for example, in the government space. But it's big on both sides. I think the problem is really complexity, and I think think about this, Moore's law, coming to data analytics, we can do other things. And you know what? It's time that we don't work for the machines, but the machines work for us. With that, thank you for your interest, and I would love to take questions if you're interested. No questions? Well, I hope at least there was some one question. Entertainment effect here.
Hey, Stefan. Jason Canellis, ESH Group. Really great talk. I like what you're trying to convey about big data and how it shouldn't take us over. At the same time, when we have a lot of enterprise and legacy programs and applications that need to talk to structured data, which means a schema, but we want to have big data in the background, how do we marry that together if we can't have Hive, if we can't have HBase, if we can't have those kind of things? Or are you saying we can, we just need to use them in more of a view kind of format?
So
thanks
for the great question. So you always have a schema. Even natural language, what sometimes we call unstructured data, has some sort of structure, right? Actually, that's the first structure we learn as human beings. So you always have structure, and you need to respect it and bring it in. But please understand that structure, the schema in your Oracle or in your Hive, is just a snapshot of right now, today. Because tomorrow your organization will change. And again, let me stress that example of the personal computer revolution, graphical user interfaces again. You know what? Under the hood, my Mac OS X is still a Unix. Right? So under the hood, we still have structured data. But I think the opportunity is really to do that concept that folks calling schema on read rather than schema on write. So respect that your trading system will have a certain schema. But if you want to do data analytics, the schema will change. But don't massage the schema when you copy the data into, for example, Hadoop. Just leave the schema as is, because that system needs that schema as is. But your analytics will have a different one. Again, the reason we had this gigantic banking meltdown is that data was copied almost 7 times, and then there was a rounding mistake in the ETL script here, and another problem here. And we kind of lost, actually, where's the data coming from? What's the referential integrity here? And where was this join happen? And how old is that data? I think the opportunity is take data with schema as is. And yes, there is a lot of schema and respect as is. But for analytical workloads, and that's the important thing, you can, on the fly, on read, change the schema and change the view on your data. And I think there's really a big opportunity. Again, I talk to the, I hear the NetApp CEOs saying, every 18 months, they change the enterprise data warehouse schema. That's why they have 2 enterprise data warehouse, one in production and one they're actually changing right now. Right, so I think that's the main difference. I don't try to say, we don't need schema. There's always schema and will apply, but just allow the machines to create the different views, the different schemas on demand, on read. Does that make sense? Okay. Any other questions? If not, well, please come to our booth if you want to have a really fun shirt, and write us an email or tweet us if you want to have that collector item that says, my Hadoop is bigger than yours. And thank you very much for spending so much time with me, of your precious time. Think about your precious time next time you write some SQL schema definitions. Thank you. Oh, one more question? I'm sorry.
I was going to do it in person, but do you find it abuse of your perspective if, like, on the schema on read, if you use like a Serde, like a regex Serde, that's basically doing it at read time, but still getting leverage of Hive, say?
It's what was the last part? It's getting.
Well, you're still going to leverage like Hive if you want that environment, but you're still doing schema on read. Like if you use, let's say, a regex Serde, or if we come up with more complex Serdes that can build schema across various underlying data formats on the fly.
Yeah, you can certainly do that, right? I think it's a crutch. I think the opportunity you have, and I mean, so here's a use case. We're working with a company that has a gigantic Hadoop environment with a Hive environment, okay? It's multi-petabyte. Well, guess what? They can't change the schema anymore because they can't offload the data because it's so many petabytes. So I think the opportunity is just leave the data as is and use something like cascading, for example, right? To create different data pipelines. And replace cascading with your favorite tool. I think there's Java, Plum, use Jekyll, if that's still supported. Kevin, you have to tell us. I think the data supply chain on demand is kind of the concept. Because if you can totally make Hive, do dynamic schemas on Hive, but actually the whole idea of Hive is the first thing you do is create a table, right? And wow, that's so 70s. You know, just take in the log files, if you ask me, as is.
Yeah, but you can still do that with the log file. Like the regex Serde, you can always change that to definition or have multiple definitions, even with which are multiple views.
I'm 100% on board with you in this context.
Thanks.
Cool. Again, thank you very much spending so much time.